This is the first in a series of little lessons which look at sine and cosine graphs, and it assumes that you've already got an understanding of the transformations in general. So we're only looking at sine and cosine. We're not looking at tan at this stage because tan is treated a little bit differently. So a sine and cosine function is anything which looks like this. The values of a, n, may be just 1 and therefore implied, not to be seen. B and C might be 0 and therefore implied as well, i.e. not to be seen. But generally speaking, that is the form of it. So what we're going to do now is we're going to have a little look, a few examples which just look at that language that we should be familiar with when it comes to transformations of graphs. And I'm going to just look at a few questions and that'll do it for this video. So here's our first example. We've got y equals negative 3 cos x, and we are asked to find the amplitude. Now, we should know that the amplitude is the dilation of the vertical dilation of the sine or cosine graph. And this number here controls the dilation. And if you say that the amplitude is equal to negative 3, you would be 100% wrong. Not really 100%, but not quite right. Remember that the minus is to do with the reflection, not the dilation. So the amplitude is 3. So we always take the absolute value of that number. And that's it. That's all you have to do if you're asked to find the amplitude. In the second example here, we have y equals negative 3 cos 2x, and you are asked to find the period. So this thing here is what controls the period. It is n. N is equal to 2. And so your calculation is period equals 2 pi, which is a standard period length for sine and cosine, divided by n, which in this case is 2, which is equal to pi. So the period is pi, which means that from one point in a graph and then go along pi unit to the next point in the graph, you would have the same y value. There we go. And the third example, and I'll zoom out and leave it zoom out so you can see all three examples now, is y equals negative 3 cos 2x plus pi on 2. What is the phase shift? Now, the phase shift is not quite this value here, not quite. It feels like it might be, but it's not. What we need to do is we need to factor out that 2 in front of the x first. So the first thing I do is go, that's equal to negative 3 cos of 2 outside of x plus pi. So again, just to note, if I went the other way, oops, sorry, that's not quite right, is it? Let's try that again. Pi on 4. So if I expanded it, I'd get 2 times x is 2x, and 2 times pi on 4, 2 goes into 4 twice, I'd get my pi on 2. So just be careful there, make sure you don't stuff up your calculations. So the phase shift can now simply be written as pi on 4. It's positive pi on 4 plus pi on 4 here, so that means that the graph will be phased or shifted to the left by pi on 4 units. And that is it.